Space is vast, it stretches beyond our imagination, an endless expanse filled with wonders and mysteries that we are only beginning to understand. It is filled with stars and planets, each one a unique world with its own story. Some of these planets are part of intricate systems, orbiting their stars in a delicate balance. Some planets are like Earth. They orbit a star, basking in its warmth and light. Others are very different. They travel alone, drifting through the cosmos without a star to guide them. We call these rogue planets. These planets are unbound, free from the gravitational pull of a star. They wander the galaxy, solitary travelers in the vastness of space. They have no star to call their own, no solar system to belong to. They are the loners of the universe, floating in the dark, cold reaches of space. They wander the darkness of space. Rogue planets are mysterious, enigmatic worlds that challenge our understanding of planetary formation and dynamics. Scientists want to know more about them. They are driven by questions that push the boundaries of our knowledge. Where did they come from? How did they form? Were they once part of a solar system only to be ejected by some cosmic event? How did they end up alone? Could they support life in some form? These questions fascinate us and drive our quest for knowledge. They push us to explore the universe's secrets, to send missions into the unknown, and to develop new technologies to detect and study these elusive worlds. Rogue planets can be large or small. Some are massive giants, while others are tiny, barely detectable. They can be hot or cold depending on their composition and history. Each one is unique, a testament to the diversity of the cosmos. Each one holds clues to the universe's history, secrets that could help us understand the formation and evolution of planets. By studying these cosmic nomads, we learn about our own place in space. We gain insights into the forces that shape our galaxy. We are just beginning to understand rogue planets. Each discovery opens new doors and raises new questions. But one thing is certain, these lonely worlds have many stories to tell, stories that could change our understanding of the universe. These solitary wanderers drifting through the cosmos remind us of the vastness and mystery of space. They are a testament to the endless possibilities that await us in the universe. Stars and planets are born in stellar nurseries, which are some of the most fascinating and dynamic regions in the universe. These nurseries are essentially vast clouds of gas and dust, often referred to as nebulae. These are vast clouds of gas and dust, stretching across light years of space. Within these clouds, the conditions are just right for the birth of new stars. Gravity pulls the material together, it clumps and swirls, creating dense regions within the cloud. Over time, these dense regions collapse under their own gravity, leading to the formation of a protostar. Eventually, a star ignites at the center. This ignition marks the birth of a new star as nuclear fusion begins in its core, releasing immense amounts of energy. Leftover material forms a disk around the star. This disk, known as a protoplanetary disk, is made up of gas, dust, and other debris that didn't make it into the star. This is where planets are born. Planets form through a process called accretion. Dust grains within the disk stick together, gradually forming larger and larger clumps. They grow larger over time, forming planetesimals. These are small, early-stage celestial bodies that can eventually become full-fledged planets. These planetesimals collide and merge, eventually becoming planets. The process is chaotic and can take millions of years. Sometimes, planets get ejected from their solar systems. This can happen due to gravitational interactions with other planets or stars. This can happen during the early stages of formation, when the system is still settling into a stable configuration. Gravitational interactions between planets can be chaotic. These interactions can lead to dramatic changes in orbits, sometimes resulting in a planet being flung out into interstellar space. A planet can be flung out into interstellar space, becoming a rogue planet. These rogue planets drift through the galaxy, untethered to any star. Some rogue planets may form alone, far from any star. These solitary planets are rare and mysterious. They may form like small, failed stars. These objects are known as brown dwarfs. These are called brown dwarfs. They are too massive to be considered planets, but not massive enough to sustain nuclear fusion like true stars. Brown dwarfs are not massive enough to sustain nuclear fusion. This means they do not shine as brightly as stars and are often difficult to detect. They are like the missing link between planets and stars, occupying a unique place in the cosmic hierarchy. Rogue planets are dark and distant. These mysterious worlds drift through the galaxy without a parent star to orbit. Unlike planets in our solar system, they wander alone in the vastness of space, making them incredibly difficult to detect. They are hard to find. Their isolation and lack of light make them nearly invisible against the backdrop of the cosmos. Traditional methods of planet detection, which rely on the light from a host star, are ineffective for these solitary travelers, but scientists have clever ways to detect them. By using advanced technology and innovative techniques, they can uncover the secrets of these elusive objects. One of the most effective methods involves the use of gravitational microlensing. One way is through gravitational microlensing. This phenomenon occurs when a massive object, like a rogue planet, passes between a distant star and an observer on Earth. The gravity of the rogue planet bends and magnifies the light from the star, creating a detectable signal. Gravitational microlensing is like a cosmic magnifying glass. It allows astronomers to see the otherwise invisible by amplifying the light from distant stars. This technique has opened up new possibilities for discovering rogue planets. It uses gravity to bend and focus light. When a rogue planet aligns perfectly with a distant star, the gravitational field of the planet acts as a lens, bending the light in such a way that it becomes brighter and more focused. When a rogue planet passes in front of a distant star, its gravity acts like a lens. This alignment is rare and fleeting, but when it happens, it provides a unique opportunity to study these hidden worlds. It bends the star's light, making it appear brighter. This temporary brightening can be measured and analyzed to reveal the presence of a rogue planet. Scientists can measure this change in brightness. By carefully monitoring the light curves of stars, they can detect the subtle signals that indicate a rogue planet's passage. From this, they can infer the presence of a rogue planet. Detailed analysis of the light curve allows scientists to determine the characteristics of the rogue planet, such as its size and orbit. They can even estimate its mass and distance. By understanding the gravitational effects on the light, scientists can make educated guesses about the rogue planet's properties. Space telescopes are crucial for detecting rogue planets. These powerful instruments provide the clarity and precision needed to observe the faint signals from these distant objects. They provide a clear view of the cosmos. With their advanced optics and sensitive detectors, space telescopes can capture detailed images and data from the far reaches of the universe. They can observe faint objects like rogue planets. By peering deep into space, these telescopes can spot the subtle signs of rogue planets that would otherwise go unnoticed. Telescopes like Kepler and TESS have already found evidence of these elusive worlds. Their discoveries have expanded our understanding of the galaxy and the many hidden planets that roam within it. Life as we know it needs energy and water. Could a rogue planet provide these ingredients? It's a fascinating question. Rogue planets don't have a star to warm them, but they could still have internal heat. This is called geothermal energy. It comes from the planet's core. Volcanic activity is a sign of geothermal energy. Some scientists believe that rogue planets could have thick atmospheres. These atmospheres could trap heat. They could also protect the surface from harmful radiation. This could create a stable environment for life to exist. However, life on a rogue planet would be very different from Earth. It would have to adapt to extreme conditions. It would have to find ways to survive in the darkness. Whether such life exists is a question for future exploration. Section 5, CFBD Sir 2149-0403. A rogue planet in the spotlight. CFBD SAR 2149-0403 is a fascinating object. It was discovered in 2012 and is thought to be a rogue planet. It is located about 130 light-years from Earth. CFBDSR 2149-0403 is special for several reasons. It is one of the closest rogue planets we know of. It is also relatively young, estimated to be between 50 and 120 million years old. Scientists are still studying CFBDSR 2149-0403, trying to learn more about its composition and history. This rogue planet provides a glimpse into the diversity of worlds in our galaxy. It sparks our imagination about the possibilities of life beyond Earth. Section 6, the Nancy Grace Roman Space Telescope, a new era in rogue planet hunting. The Nancy Grace Roman Space Telescope is a powerful new tool. It is set to launch in the mid-2020s. It will revolutionize our understanding of rogue planets. This telescope is designed to find planets using microlensing. It will be much more sensitive than previous missions. It will be able to detect rogue planets that are smaller and fainter than ever before. The Nancy Grace Roman Space Telescope will observe millions of stars. It will look for the telltale signs of microlensing events. Scientists expect it to find thousands of new rogue planets. This will give us a much better understanding of how common these objects are. Section 7, Euclid, Charting the Dark Universe and its Rogue Inhabitants. Euclid is another exciting mission. It is led by the European Space Agency. It is also scheduled to launch in the mid-2020s. Euclid will create a three-dimensional map of the universe. Euclid will study dark matter and dark energy. These are mysterious forces that make up most of the universe. But Euclid will also be able to detect rogue planets. Euclid will use a technique called weak gravitational lensing. This technique measures the distortion of light from distant galaxies. Rogue planets can cause subtle distortions in this light. By analyzing these distortions, Euclid will be able to identify rogue planets across vast distances. Section 8, Rogue Planets, Unlocking the Secrets of Planetary Evolution. Rogue planets are more than just curious objects, they are valuable clues to the universe's history. They can tell us about how planets form and evolve. For example, studying the composition of rogue planets can reveal information about the conditions in their birth clouds. Their distribution in space can provide insights into the dynamical interactions that shape planetary systems. Furthermore, understanding the prevalence of rogue planets can help us refine models of planet formation. It can tell us whether ejection from solar systems is a common occurrence. This knowledge can be applied to our own solar system, shedding light on its early history. Section 9. The unending quest to understand our place in the cosmos. The study of rogue planets is a testament to human curiosity. We are driven to explore the unknown. We want to understand our place in the vast universe. These lonely wanderers challenge our assumptions about planetary systems. They force us to expand our horizons. They remind us that the universe is full of surprises. As we continue to explore the cosmos, we are sure to find even more strange and wonderful objects. Rogue planets are just the beginning. The universe is full of wonders waiting to be discovered, and we, the curious explorers, are eager to uncover them.